Let's talk through the basicity of amines. And first, we need to, of course, know what a base is. For AQA chemistry, we only really learn one definition for acids and bases, and those are our Bronsted-Lowry acids and bases, where acids are proton or H plus donors, and bases are proton/H plus acceptors. So in order to accept a proton, we need a lone pair. And so when we're considering the amines, all of our amines are essentially based on what I like to call the mother amine, which is ammonia, so just NH3. And if we think of ammonia's basic activity, we know that there's a lone pair on the nitrogen, which can be used to accept a proton, so an H plus. So when we're talking about the basicity of amines, which is where instead of having all three hydrogens, one, two, or all three of those hydrogens have been replaced by something else, okay, then we can compare them to mother amine, ammonia, okay? What's going to affect the basicity is whether the group that's attached to the nitrogen is pulling electrons away from it, making the lone pair less available, or pushing electrons towards it, making the lone pair more available. Okay, so I have put this in the context of kind of an exam-ish style question, even though there's no question. The question is, which of these three amines is the strongest base? So let's answer the question with the explanation at the same time. So if we start with A, this is a primary, oh, actually, should I go? Yeah, a primary aliphatic amine. Aliphatic essentially just meaning that it's not aromatic, so there's no benzene ring, for example. So with this lone pair on the nitrogen, our question is, are electrons being pushed towards that nitrogen, or are electrons being pulled away from that nitrogen? Now, if we link our understanding all the way back, thinking to electrophilic addition with alkenes and the stability of carbocation intermediates, we know that alkyl groups, so this CH2, CH3, has got a positive inductive effect. Let me just write the words. Positive inductive effect, or in simpler terms, we can say it has an electron pushing effect, meaning it's pushing electrons towards this nitrogen, increasing its electron density and making that lone pair even more available. I'm going to make it really dramatic, even more available to accept an H plus. So in comparison to ammonia, this amine is going to be a stronger base than ammonia. Okay, but is it stronger than these two? Well, let's find out. If we go over to B, B is an aromatic amine, specifically phenylamine, where we've got our benzene ring and then our amine group is directly attached to the benzene ring. Sometimes you might see it called aminobenzene, phenylamine, depends what you're reading, okay? Now again, if we consider the lone pair on this nitrogen, we ask ourselves, are electrons being pushed towards that nitrogen, making that lone pair more available, or are electrons being pulled away from that nitrogen, making the lone pair less available? Well, when it comes to this benzene ring and these delocalized pi electrons, what happens is the lone pair from the nitrogen actually gets involved. I'm going to draw it just like this. The lone pair gets involved in the delocalization. So the lone pair is delocalized. Lone pair delocalized into the benzene ring. Now, if the lone pair is now involved in here, that means that it's less available on the nitrogen to actually accept a proton. So this will be a weaker base. We can start here. This will be a weaker base than our ethylamine. Is that ethylamine? Yes, it is. Because the electron density is being pulled away from the nitrogen rather than being pushed onto it. If we come over to C, now C is a bit of a hybrid, right? We can see that it's a secondary amine, but it's got two different actions happening on either side, right? We've got just your standard R group, that's just your methyl, that's a CH3, just to make that super, super clear. And we know that alkyl groups like methyl are going to be electron pushing or electron donating or have a positive inductive effect, making the lone pair on the nitrogen more available. However, our aromatic ring, our benzene, has the opposite effect, so it's pulling electrons away from that lone pair. So overall, we could probably then surmise that amine C is going to be a stronger base than amine B, but a weaker base than amine A, which has only got a positive inductive effect. Okay, so to summarize, basicity of amines is the group pushing electrons towards it, is the group putting electrons away from it, and how does that affect the availability? Can I spell availability is the question. Availability, thank you, of the lone pair on the nitrogen of atom of that amine. For more A-level chemistry lessons, support, advice, practice, make sure that you have liked, commented, and subscribed, and I will see you in the next one.